You know how to add a few numbers, right? But what if I told you to add up every single number from 1 to 100 by hand? Yeah, sounds pretty awful. But don't worry, because today we're going to learn a little mathematical secret to solve problems just like that in seconds.
So what's your gut reaction here? You'd probably just, grab a calculator and start mashing buttons. But think about it. Adding them one by one isn't just slow. It's a perfect recipe for making a mistake. There's got to be a better way, right?
And you bet there is. A much smarter way. We are absolutely not going to add these up one by one. That's the brute force method. And you know what? We're way better than that. So here's our game plan. First, we'll lay out the problem. Then, we'll get our key terms straight. After that, I'll show you the magic formula. And we won't just look at it, we'll prove why it works, run through a couple examples, and then wrap up with the big takeaways. Sound good?
Yeah, this is what I like to call the forever adding problem. You know, when you have a list of numbers that follow a nice, neat pattern, like an arithmetic progression where you're adding the same amount each time, trying to sum them up by hand is, well, it takes forever, and it's just so easy to mess up. All right, before we jump into the solution, we need to get a couple of key terms straight. There are these two words that people mix up all the time: sequence and series. They sound similar, for sure, but in the world of math, they mean totally different things. And the difference is actually super simple. A sequence, that's just the list of numbers, separated by commas. But a series, that's what you get when you actually add all those numbers up. So remember, sequence is the list, series is the sum. Okay, here's a really cool way to think about it that might help. Imagine a sequence is like the individual steps you take on a long walk. Each step is a term. The series, then, is the total distance you've traveled. That little analogy, it's going to be really helpful for what's coming next, so keep it in mind.
Okay, now that we've got our definitions down, it's time. Time to bring out the hero of our story. This is it, the elegant, super powerful tool that's going to solve our forever adding problem in a snap.
And here it is. The sum, which we call S sub n, equals n over 2 times a plus l. Okay, so what does all that mean? Well, n is just how many numbers you're adding. A is your very first number, and L is your last one. That's it. Simple, clean, and you're about to see just how powerful it is.
But wait, you might be thinking, what if I don't know the last term? No problem at all. There's another version of the formula for that exact situation. In this one, you still use the first term a and the number of terms n, but instead of L, you just need d, which is that common difference, the number you're adding each time.
Look, you could just memorize these formulas and call it a day. But if you really want to get it, if you want to make sure you never forget them, you got to see why they work. That's what we're going to do now. Build some real intuition.
This is so cool. It's called the pairing method. So check this out. Let's take the series 2 plus 5 plus 8 plus 11 plus 14. Okay, you write that down. Now, right underneath it, write the exact same series, but backwards. So 14 plus 11 plus 8 and so on. Now for the magic. Just add the numbers vertically. What's 2 plus 14? 16. What's 5 plus 11? Also 16. 8 plus 8, you guessed it, 16. Every single pair adds up to the exact same number, which is always the first term plus the last term, a plus l. And since there are n terms, you have n of these pairs, right? But hold on, we counted the series twice. So what do? We just divide the whole thing by 2, and boom, there it is. N divided by 2 times a plus l. Isn't that brilliant?
All right, enough with the theory. That was the why. Now let's get our hands dirty and actually put these formulas to the test with a couple of examples.
Okay, example number 1. We need to find the sum of the first 20 terms of this series, 3, 7, 11, 15, and so on. So first things first, what do we know? Well, our first term, a, is 3. The common difference, d, is 4, because we're adding 4 each time. And n, the number of terms, is 20. So we can use that first formula. But wait, we need the last term, L. A quick little side calculation tells us that the 20th term is 79. Perfect. Now we just plug everything in. S20 equals 20 divided by 2 times our first term, 3, plus our last term, 79.
And that just gives us 10 times 82 for a final answer of 820. I mean, think about that for a second. We just added 20 different numbers in a few seconds? No calculator needed. That, right there, is the power we're talking about.
All right, let's do one more. This time, we're going to pretend we don't know the last term, so we have to use our other formula.
We want the sum of the first 10 terms for the series starting 5, 12, 19. So let's see. What do we have? Our first term a is 5, the common difference d is 7, and n is 10. Let's plug it all into that second formula. S10 equals 10 over 2 times, get this, 2 times 5 plus 9 times 7. That just simplifies down to 5 times 73, which gives us 365. Done. See? Super fast, super efficient. It's all about using the right tool for the job.
So let's recap. We've seen the problem, we've learned the formulas, and we even proved why they work. Now let's just wrap this all up with the most important things you need to walk away with.
Okay, here are a few exam tips, some common traps to avoid. First, always double-check n, the number of terms. It's so easy to get that wrong. Second, don't mix up the common difference d with the last term l. They're totally different things. And finally, just know which formula to grab. If you don't have that last term, you know that second formula is your go-to.
And hey, this isn't just some abstract thing for a math test. This stuff actually shows up in the real world all over the place. You could use it to figure out your total salary over 10 years if you get the same raise every year. Or, in physics, to calculate the total distance a car travels. It is a surprisingly practical and useful tool to have. So here they are, one last time, your 2 key formulas, the essential tools for your mathematical toolkit. Just remember, it doesn't matter if you know the last term or not. One of these will get you the answer, and it'll get it for you fast.
So we've totally mastered how to add up a finite list of numbers. 50, 100, even 1,000 terms, no problem. But that brings up a much bigger, kind of mind-bending question, doesn't it? What happens if that list of numbers just never stops? What if the series goes on forever? Well, that's a whole other adventure for our next explainer.